Section 5, Quantum Ontology and Free Will. Stapp first gives the conventional answer to this discreteness problem. It is, he says, resolved in orthodox quantum theory and in actual scientific practice by what Heisenberg and Bohr call a choice on the part of the experimenter. Stapp points out that von Neumann calls the manifestation of this choice in the physical world process 1. Stapp then proposes another process, which he calls process 0. This is the process that selects the particular partitioning specified by the physically described process 1. Stapp is clear, however, that this partitioning cannot be caused by a physical acting alone. Continuous smears acting in accord with the smoothing Schrödinger equation cannot create a discrete partitioning in a finite time. On the other hand, Stapp says, the experimenter feels that his consciousness is playing a role. Indeed, if the physically described aspects alone cannot do the job, and it feels like consciousness is helping, then why not try that idea out? Consciousness is, after all, the only other thing in our ontological arsenal. Stapp concedes that the classical intuitions of neuroscience about the brain are generally valid. However, he insists that there are two exceptions. Firstly, at almost every instant, the cloud of possibilities is growing and diffusing into a wider set of possibilities, which, however, every once in a while, at a reduction event, gets reduced to a subset. Secondly, the diffusing action can be curtailed by the quantum Zeno effect, which arises from the small but non-zero quantum smearing of each one of the almost classical components. Consequently, says Stapp, the brain can be described in a strictly quantum mechanical way, and yet it can be understood to be very similar to a classical statistical ensemble. Importantly, the relevance of the quantum aspects for consciousness is not due to some macroscopic quantum superposition effect, which would be extremely hard to realize. The pertinent non-classical feature is the occasional occurrence of a sudden reduction of the ensemble to a subensemble that is compatible with the content of a co-occurring conscious experience. These reductions decompose or partition the expanding ensemble of almost classical states. Stapp claims that it is only by means of this partitioning that the theory is tied securely to human experiences and to the empirically validated rules of quantum theory. He insists that such reductions are logically necessary in order to decompose the continuous structure of the expanding ensemble of almost classical states into a collection of discrete alternatives, each associated with a distinct kind of experience. The smear of almost classical possibilities must be partitioned prior to each experience into a specified collection of components, at least one of which corresponds to a distinctive experience or lack thereof. In order to define what he calls a template for action, Stapp starts by quoting William James, who wrote that no object can catch our attention except by the neural machinery, but the amount of attention that an object receives after it has caught our attention is another matter. It often takes effort to keep mind upon it. We feel we can make more or less of the effort as we choose. This feeling will deepen and prolong the stay in consciousness of innumerable ideas which else would fade away more quickly. Stapp argues that such a conscious effort to act in an intended way will produce a neural correlate in the form of a specific pattern of brain activity which may extend over a large portion of the brain. This pattern of neurological activity, which is produced by a process 1 action, if held in place for a sufficiently long period, will tend to produce a brain activity that will tend to produce an intended experienced feedback. According to folk psychology, we all believe that conscious effort is A, under our own control, and B, has the effect of intensifying whatever experience to which we apply it. Stapp claims that increasing effort increases the rate at which conscious events will occur, and that if the rate becomes sufficiently great, what he calls the quantum Zeno effect will kick in. Via the repetitious interventions of probing actions, the Zeno effect will tend to hold templates for action in place. That effect will, in turn, tend to make the intended action occur. By virtue of this dynamically explained causal effect of willful conscious effort upon brain activity, trial and error learning should hone the correlation between the consciously experienced intention and an associated template for action that produces, via the physical laws, the intended feedback. This explains dynamically the capacity of an effortful intention to bring about its intended consequences. Stapp points out that this account of conscious causation does not involve the action of any forces, mental or otherwise, upon the parts of a material substrate. No pushing around of the atoms in a way that produces, in some totally miraculous and unaccountable way, the action that the person has in mind. No. The effect of the effort is on an entire macroscopic neural pattern of brain activity. This pattern has been singled out by von Neumann's process 1 action and is held in place by the quantum Zeno effect. This coupling of von Neumann's dynamical rules to learning can account rationally for the observed correspondence between experienced intent and experience feedback, both of which are, of course, essential for human life and survival. Stapp states boldly that there is no rational controversy about whether or not quantum effects occur in the brain. Of course they do. The crucial question is the extent to which the quantum as opposed to classical percepts are essential for the dynamics of the brain, and to what extent a classical approximation is valid in a warm, wet, noisy brain. To answer these questions, Stapp says we must examine how well the possible quantum effects can survive in an environment that is potentially lethal to many of them. Careful analysis shows that one particular quantum effect, the quantum Zeno effect, can survive and indeed can play an essential role in the causal relationship between a mind and its brain.